This is again a question from the year 2024. If you have seen the previous question, that is question number 18, this is actually a very easy problem compared to that. And the concepts are almost overlapping. So let's see. There is a can X containing, so X contains, X contains 399 liters of petrol, and Y contains 532 liters of diesel. They are to be bottled in bottles of equal sizes. The bottle should be of equal sizes, so that whole of petrol and diesel to be separately bottled. The bottle capacity is in terms of liters is an integer. Okay, so the bottles should be an integer like 1, 2, 3, something like that. How many different bottle sizes are possible? See, this is actually a very easy problem. To explain this, it would be much more easier if I take a smaller number. Okay, so to explain this, I'm going to take some smaller number. Let's say I'm going to take the numbers 5 is too less, 12 liters and our usual 18 liters. Let's assume that there are two bottles, 12 liters and 18 liters. If I want to bottle them in bottles of the capacity in integers, then I should be selecting such numbers we should be able to divide these numbers. That means if I take, let's say, 1 liter bottles, then of course I can bottle all the 12 liters. I can bottle all the 12 liters in 1 liter bottle. I have to just take 12 bottles. Okay, so 1 is a possibility. Or I can even take 2. I can take 2 liter bottles. I just have to take 6 such bottles. Okay, 2 liter bottle is also possible. Now what am I happening? 12 is divisible by 1. So 1 is a factor of 12, or 1 can divide 12. That is why 1 is okay. 12 is also divisible by 2. That basically means 2 is a factor of 12. So 2 is also okay. Even 12 divided by 3, 3 is also perfectly divisible. All I have to do is I have to take 3 liter capacity, such that I need 4 bottles. Even 4 liter is also fine. 4 into 3. But if you look at 5, this is not fine. Because imagine if I have 5 liters. 5 liter plus 5 liter will give you 10 liters. Now if I take one more bottle, that's supposed to be at 15. But I only have 12 liters. So in the last bottle, I'll be only able to put 2 liters. So the first 2 bottles will be completely filled. First 2 bottles will be completely filled of 5 liters and 5 liters. And the last 5 liter bottle will only be 2 liters filled. 3 liters will be empty. This happens because 12 is not divisible by 5. It's not divisible. You are going to get a remainder too. So basically, we are only supposed to take such numbers which can divide this given number. Or we are basically looking for the factors of this given number. And thus, we will be finding the factors of 12. 1, 2, 3, 4, 6, 12. This many factors are there for 12. And how to find factors, etc. you can find in the very previous video. That is, this is question number 19, question number 18. For example, 18. 18's factors will be 1 into 18, 2 into 9, 3 into 6. That's it. So 1, 2, 3, 6, 9, 18. The 12 liter capacity can be bottled in these many different containers, different volume of containers, and 18 liters can be contained in this many. Now we are looking for a common size bottle. This bottle should be able to fit both the case. So we are looking for common factors. So first we found factors, now we are looking for common factors. So 1 is common, 2 is common, 3 is common, 4 is not there, 6 is common. So all these capacities 1, 2, 3 and 6, if we are selecting bottles of that capacity, I can bottle both 12 liters and 18 liters in perfectly, we can perfectly bottle them. Now in the previous question I also told you, to find common factors, the easiest way to find all the common factors is just find the highest common factor, or HCF. in this common factors, the highest guy is this 6. Therefore, that is our value. Okay. So we are looking for HCF, and after finding the highest common factor, you simply find all the factors of this HCF, all the factors of 6. If you look at the factors of 6, those will be 1, 2, 3 and 6. You see, 1, 2, 3 and 6, the same value you are going to get here. So to find all the common factors, you just have to find the common HCF and then find all the factors of the HCF. Now again, to find HCF, I have told you multiple methods. One method is prime factorization. 12 can be written into 2 square into 3. 18 can be written as 2 into 3 square. Take whatever is common. Only take whatever is common, and out of them take the smallest power. 2 raised to 1. Here 3 raised to 1. That is 6. That is one way. Second way is take the bigger number, divide that with the small number. It will go one time, subtract, balance is 6. Now take the previous divisors and divide that with the current remainder. 2 times 12, 0. Whenever you get 0, the value you used for dividing, that will be your HCF. Okay. So this is a easier method to find HCF, especially when the number is big. So in this case, we again have to find our HCF. So we are going to look for HCF of these two numbers. Let's find that. Let's use this method. So I'll take the bigger number 532, divide that with 399. One time it will go 399, and balance here. Oh, let me change the color. Okay, I'm going to divide. It should borrow. This will become 2. This will become 12. 12 minus 9 will give you 3. Again, I have to borrow. This will become 4. 12 minus 9 will again give you 3, and 4 minus 3 is 1. Now I am going to divide the previous divisor 399 with the current remainder 133, and you will be getting, it will go 3 times 399, and that is 0, 0, 0. Okay, so our HCF of these two numbers will be 133. So we found the HCF. Our HCF is going to be 133. Now all we have to do is find the factors of this 133. See, it will be much more easier if we can divide this number of prime factorize 133 to find its factors, or basically we are looking for some numbers which can divide this number. See, the first thing which we need to know is that whether 133 is a prime number or not. To check if this number is a prime number or not, what you have to see is that just see if it is a perfect square. If it is not a perfect square, look for the nearest perfect square which is above this. The perfect square above this, I think it should be of 12 squares, because 12 square is 144, and that is the nearest perfect square. So I'm going to take that. So all I have to do is check if this number is divisible by all the prime numbers before 12. So I'm going to check 133. If it is divisible by the first prime number, which I know is 2. No, this number is not divisible by 2, because last number is not, last digit is not even. Okay. Oh, is it not erasing? Yeah. So the next prime number is 3, next prime number is 5, next prime number is 7, next prime number is 11. I only have to check with them. Is it divisible by 3? I will add all the digits, 1 plus 3 plus 3. That is not 6, 7. That is not divisible by 3. So it is not divisible by 3. Now I'm checking with 5. The last digit is not 5 or 0. It is not divisible by 5. Checking the divisibility of 7. How to do that? Take the last digit, double it, subtract from the rest. I will be getting 7. And this number is divisible. So this number is also divisible. So this number is divisible by 7. So I'm going to simply divide that with 7. If I divide that with 7, one time it will go. 7 balance is 63. That is 19. It's a prime number, so I can stop here. So the number 133, could be written as 7 into 19. Only 2 prime factors are there. Therefore, if I check all the factors of the number 133. I will find that, of course, 7 and 19 are factors. One more possibility is there for 133. One more possibility is there for 133, and that is the original numbers 1 into 133. So I have 1 and 133. There's only 4 factors for this given number. Okay. Now, I was looking for the number of factors. This is actually finding the factors. I don't have to find the factors. I just need to find the number of factors. To find the number of factors, see, this is an easy number. If it is a harder number, or we need to use a proper method. And that method is, of course, prime factorize this number, 7 into 19. Then take the powers, the number of factors. You can find the number of factors by taking the power and add 1 to it. Take the next power, add 1 to it, and then multiply. So you're going to get 2 into 2, that is 4. See, that's the same thing which we got. 1, 2, 3, 4. 4 factors are there. We found also that the number of factors will be 4. So all these numbers 1, 7, 19 and 133 could be used as the capacity of bottles. So there are 4 possible bottle sizes. So answer for this problem is option B, 4. Now again, we'll just see, that's it, this problem. This is an easy problem. Okay, if you know the principles. Now I'm again going to say some more theories, some methods of finding HCF, and also this number of factors. Okay, so let's assume that I have 3 numbers, A, B and C, and the numbers are 2 square into 3 cube into 5. Option B, 3 square into 5 cube into 11. Let me put 11 square here also. And the last number will be 3 raised to 4 into 5 raised to 4 into 70. Now, if I imagine I have 3 numbers, now I'm going to find the HCF of these numbers. To find the HCF, see, first of all, you guys try to find the HCF of these numbers. Okay, you can pause the video and try. I'm going to give you the answer. Okay, the HCF of this number, we can only take the number which is common in every way. The first step is that, of course, everything should be in the standard form, in the prime factorized form. Now, after that, take the number which is common everywhere. See, 3 is common, 2 is not there, only 3 is common. And after taking 3, take the smallest power. Smallest power is 2. So 2. Okay. Similarly, 5 is common. Since 5 is common, I'm going to take 5. Now, you have to look for the smallest power, that is over here, 1. 1. Now, if you look at 11, 11 is only there in 2 places, so you cannot take that. 17 is only there. So, this is the HCF of this given number, that is 9 into 5, which will give you 45. Now, similar to this, there is another concept known as LCM. Okay, I'm just going to give you that also over here. If you want to find the LCM of these given numbers, to find the LCM, what you have to do is take, if something is not common, for example, this 2 square is only available there, just take it as it is. Now, if someone is common, okay, for example, this 3 cube, 3 is common, you take that 3 and after that, directly opposite, you take the highest possible power. Here we have 4 as the highest possible power. Now again, look at 5. 5 is there everywhere. You'll take 5. Now out of the 5, you will take the highest possible power, that is 4. Now if you look at 11, 11 is an interesting phenomenon because it's not common everywhere, but it is only available in 2 places. That's fine. You'll still round it, and from there, you are going to take the highest possible power, that is 2. And finally, 17 is all along here. You'll take that as it is. So this is the way of finding LCM. LCM stands for least common multiple or lowest common multiple. We'll see about that later. Okay. So this is the actual method of finding HCF and LCM. Now, the number of factors. That's another concept which I want to tell you. For any number, for example, 2 square into 3 cube into 11. 11 basically means 11 raised to 1. If you want to find the number of factors, first you have to write it like this in the standard form. Make sure that it is in the standard form. For example, the same number could be written as 2 square into 3 square into 11 into 3. See, the number is same in both the case, but the bottom one is known as the standard form. This is the standard form, and this is some random thing. Why? Because 3 square and 3, this should be joined together. 3 square into 3 or 3 raised to 1 is 3 square plus 1, that is 3 cube. It should be written always like this. If a prime number is there, it should be brought together. So this is not the standard form, this is the standard form. First step is writing the numbers in the standard form. Once the numbers are in the standard form, then you can find number of factors of this number will be, take the power, add 1. Again, take the power, add 1. That color was not a good choice. Let me change it. Take the power, add 1. Similarly, take the power, add 1, and then multiply all of them together. You will find the number of factors. Here this will be 2 plus 1, that is 3 into 3 plus 1, that is 4 into 2. So you will get 3 into 4 into 2. You will get 24. This given number have 24 factors. Okay, so that is how you find the number of factors. I can give you some practice problems. First thing, in HCF and LCM case, I'm going to give you a practice problem. A is equal to 2 square into 3 cube into 5 cube into 11 square. B is equal to 2 raised to 4 into 3 square into 7 square into 13. C is equal to 2 raised to 5 into 7 cube into 11 cube. I want you guys to find the HCF and LCM of these numbers. And one more problem that will be to find the number of factors. Let's take the number x. The number x is 2 cube into 3 square into 5. And one more number y, which is 3 cube into 2 square into 11 into 2 cube into 7. I want you guys to find the number of factors for the ones written on the right and HCF and LCM for the number on the left. Okay, you can pause the video and try to find the answer. I'll give you the answer right now itself. Okay, I'm going to give you the answer. If you need more time, please feel free to pause. To find HCF, only take the people who are common, that is 2, and take the smallest power, which will be 2. Is there anyone else common? 3 is not common, 7 is not common, 5 is not common, 11 is not common, 13 is common. That's it. That's HCF. HCF is 4. Now, if you want to find, see, HCF is a person who cares too much for his diet. He will only take the number which is common everywhere, and that to the lowest. On the contrary, LCM is a person who will eat everything. If he will even eat plates. So if someone is common, he will take the biggest value, 2 raised to 5. If someone is only common in 2 places, still fine, he'll take the biggest value, 3 cube. 5 cube is only there, doesn't matter, he is gonna take that. 7, how? 7 is only available there, you'll take that, 7 cube. 11 is only here, doesn't matter, take the highest power, 11 cube. And finally this 13 also. So that is the LCM. You don't have to find the exact value, that itself is the LCM. Now let's find the number of factors. To look for the number of factors for this number, this is already in the standard form. So number of factors will be 3 plus 1 into 2 plus 1 into 1 plus 1. That is 4 into 3 into 2. Again, 4 into 3 into 2. You are going to get 24. Now the next number. Okay, hope you guys saw that. The next number. The color is a little bit bright. For this number, first I am going to check if this is in standard form. No, 2 square and 2 cube. They are two separate stuffs. I have to bring them together. If I rewrite this number, it is going to be, let's write it properly. 2 square into 2 cube is 2 raised to 5 into 3 cube into 7 into 11. Okay, now it's in the standard form. Number of factors will be 5 plus 1, that is 5 plus 1 into 3 plus 1 into 1 plus 1 into 1 plus 1, that is 6 into 4 into 2 into 2. 6 into 4 into 2 into 2, which will give you answer as 96 factors will be there for that given number. Okay. Now one more thing, whenever a problem comes, if you want to identify if it is an HCF or an LCM, which you have to do, all you have to look for is that you have to see if you're looking for factors or multiples. Okay, you know factors, a number which can divide this given number is known as its factors. Multiple is something which you can create. Take any number, let's say 5. The multiples of this number will be simply 5 multiplied by any natural number. So 5 is a multiple of 5. 5 into 2, 10 is a multiple of 5. 5 into 3, 15 is a multiple of 5. 5 into 100, 500 is a multiple of 5. And 5 into, any numbers. 5, 5, 5. 555 is a multiple of 5. So multiple, all you have to say is that if you're looking for a factor or multiple, that's how you start to identify if the problem is based on HCF or LCM. And that's it. Thank you. See you with the next problem.